Good afternoon, and welcome to the Institute for Critical Infrastructure Technology webinar, the newest attack vectors, infrastructure as code and API security virtual briefing. I am Joyce Hunter, the Executive Director of ICIT. During this webinar, our panelists will share their thoughts and practical experience in the following areas: architecture, provision services, and operations. Before we proceed, I would like to thank DLT and Checkmarks for sponsoring this event and bringing this hot off the presses topic to our participants. So who is ICIT? The Institute for Critical Infrastructure Technology, ICIT, is the nation's leading cybersecurity think tank, providing objective, nonpartisan research, advisory, and education to legislative, commercial, and public sector cybersecurity stakeholders. Our mission is to cultivate a cybersecurity renaissance that will improve the resiliency of our nation's 16 critical infrastructure sectors, defend our democratic institutions, and empower generations of cybersecurity leaders. And we invite you to become part of the ICIT community through individual or corporate membership, event, or special publication sponsorship. Now I am going to introduce our moderator for today. Nick Sinai is a venture capitalist with Insight Venture Partners, adjunct faculty at Harvard Kennedy School, and a former senior official in the Obama administration. Nick Sinai was the Deputy Chief Technology Officer of the United States. He assumed this role under the second Chief Technology Officer of the United States, Todd Park, and continued under Megan Smith. Sinai was formerly a senior advisor to Park, as well as the first US CTO, Anish Chopra, starting in 2010. Sinai is a regular contributor to the TV show Government Matters and has been quoted in the Washington Street Journal and The Economist. Thank you very much for joining us, Nick, and I'll turn this over to you.
Thanks, Joyce. Really excited to be here. I am fired up. We have such a great panel today and a really interesting topic. So first, let me introduce the panelists. We have Nick Shalon, who's not quite on, but we'll see him momentarily. He's the Chief Software Officer and co-lead for the DoD Enterprise DevSecOps Initiative. He's also a serial entrepreneur. We have Carrie Lee, who's a Senior Technical Advisor at the U.S. Department of Veterans Affairs. She has a background in all things cyber and specializes in cloud and emerging technology security. We have Elizabeth Schweizenberg, who's a digital services expert at U.S. Digital Service. She has a cybersecurity and incident response roles at Facebook and Google prior to entering USDS. Chris Hughes, who's the principal cybersecurity engineer at Rise8. He was active duty U.S. Air Force, a civil servant with U.S. Navy, and at General Services Administration, FedRAMP, and is now a consultant in the private sector. So let me try and set the stage a little bit, and then we'll jump into a great conversation here. So software is eating world, as we all know, and it's eating government too. And if we're going to rebuild the economy, if we're going to build back better, recover from the pandemic, meet our most important mission set, then we're going to have to buy, build, and integrate software better. And as I think we all know, that means that we have to bake security in and do security better. And I'll give you an interesting stat that Gartner says that over 70% of security vulnerabilities exist at that application layer, where we are building and integrating software, not at the network layer. So it's clear that application vulnerabilities are among the most exploited vulnerabilities that hackers use to compromise and breach organizations. But you know, AppSec is changing the application security sector because how we design, develop, and deploy software is changing. And so there's two areas in particular that I wanted to focus on today, and one is APIs, application programming interfaces, and the other one is infrastructure as code. So let me set the stage briefly on APIs and talk about why they're so interesting. I think there's really two pieces to it. One is APIs help government agencies make their data available to stakeholders, to researchers, and even the general public. So third-party app developers, all kinds of folks can ask for the data they need rather than downloading it in bulk. I had the great privilege of working on the Blue Button Initiative during the Obama administration and other personal data initiatives where we're trying to make personal data available to consumers so they could download that data, but they could also authorize third-party apps, and you'd use an API for something like that. And we'll hear a little bit more about how veterans can download their VA medical record to their mobile phones. And then internally, APIs are being used a lot because we're moving from kind of these big monolithic apps that took years for developers to build to more microservices, where we're actually breaking down applications into different pieces. So just to give you an example, if you think about online retail, you could imagine an application or a microservice that handles credit card payment processing. You could imagine another piece that checks inventory, another one that does fulfillment. So instead of one single application that does all those things, we kind of have these mini applications, and the way you tie them together is APIs. So APIs is what lets different things talk to each other, both externally and internally. But we got to secure them. And in fact, there's been some challenges. The State of the API Security Report released by SALT says that 90% of respondents claim to have experienced an API security incident in the previous year, and that 66% of respondents delayed the launch of an application due to an API security concern. So the other area, and very much related, is infrastructure as code. So let me explain. Infrastructure as code is essentially a way to automate the deployment of infrastructure that runs and houses software and applications in cloud environments. So traditionally, we did this with hardware, bare metal devices that lived on premise in data centers. And with the rise of the cloud, this has shifted to code. So it streamlines the provisioning and configuring process, but it also automates it. And so now as the cloud becomes more popular, developers are being able to move to DevSecOps, development, security, and operations all integrated together. And so the large cloud providers like the AWS, Google, and Azure, those and other hybrid cloud solutions are kind of the preferred infrastructure now for developing and deploying those applications. But we have to build repeatable scripts to deploy that infrastructure, and instead of physically deploying servers. And the challenge here is if you write a script that has security issues, then you can actually cause problems at real scale, right? So we can still configure and provision insecurely, and if we automate that process, we can actually make life even worse for ourselves. So just because we are doing things in the cloud, just because we are automating things, doesn't mean that it is magically secure. We have to use some of the same security principles around authentication and authorization, data validation, and so forth. And we'll jump into all those topics. So let's jump into the panel conversation. I hope that sets the stage on API and infrastructure as code security, why they're a little bit different from traditional application security, but also somewhat similar because some of the same principles may apply, even though these are a little bit different. So Carrie, let's start with you. You're working on a really interesting API program at VA. Can you give us a little bit more background on Project Lighthouse?
Yeah, thank you, Nick. So Lighthouse is our award-winning API platform that's reinventing the way veterans and their families engage with VA. So we give developers secure access to VA data they need to build helpful tools and services for veterans. It's streamlined and accessible. We designed a modern API experience to easily build services that provide veterans with consistent and reliable access to their data. So what our goal is with Lighthouse is through our digital transformation, we wanted veterans to have the data they needed to make decisions, or to, like if they went out to a community care provider, instead of seeing a VA person, they can download their health record through APIs and be able to use that to show the community care provider. We also have the ability to validate benefits or validate claims. Another piece is facilities. Generally, facility addresses and so forth are open data. They're available to the world. Well, we use our APIs so that applications can call them to get information on VA facilities. So Lighthouse is our front door to VA's data stores. It's a singular platform that hosts APIs that are accessible externally and gives mobile applications access to our data.
It sounds, oh, sorry, go ahead.
Oh, go ahead, Nick.
I was just gonna say, it sounds really cool in that it is both for other groups at VA and a whole ecosystem of partners and then veterans themselves across benefits, facilities, health, veteran verification. It sounds pretty comprehensive.
Right. It is comprehensive. It's the way we share data with the external world, so we can give the veterans that modern experience that they're able to get with private healthcare providers. And oh, go ahead.
Oh, I'm sorry. I got a little delay. I'll knock it off. I'm being a lousy moderator. But just given that context, I'd be curious, how you guys are thinking about securing this program.
Okay, so basically, we're taking security very seriously. We want to keep our veterans' data safe yet be accessible. So in order to, first off, give organizations the ability to connect to our APIs, we have a site called developer.va.gov. And within there, you can request a key to get access to our sandbox where organizations can start developing applications. But actually, in order to connect to our production environment, they have to be vetted significantly. So basically, they have to give us a demo and we interview them about their security practices and the reasons that they're actually requesting access, how they're protecting their keys. The veteran data we have to ensure stored in a trusted area on a veteran's device rather than traversing the company's system and being stored there. We review their terms of services and privacy policies, and they are required to answer any additional questions that come up through that demo. They must also agree to our terms of service and operate within those boundaries. And before a veteran uses one of those apps to download their data, they must consent to sharing their data with that application. So it's not like, oh, we have an app that can download a veteran's health record, so as if they install it, they can do it, but the veteran actually has to consent to that. So that's one initial way when we're looking at apps connecting to our environment that we protect. But we really apply holistic layered security. We are not just about building the APIs, but we are securing them using defense in depth. And we use best practices for APIs. So we use OAuth and OpenID Connect for identity authentication and authorization. And we use an API management gateway. We centralize external API access. We provide network security measures. And we use DevSecOps practices in building the APIs. So I can discuss some of the specific practices we employ with our APIs within those areas. So in order to prevent denial of service attacks, we enforce rate limiting and quotas. And that will keep our backend databases, if a lot of requests are coming in, from failing. And as I said, we use OAuth for authentication and authorization. And within those OAuth tokens, we set short time limits for so that they expire within a certain amount of period, and they're not good for a long time. And when requests come in and when the data is sent out, we validate tokens in both directions. We don't just like get a token and then send it out. We validate in order to provide that extra layer of security. We follow government regulations. So TLS is used for to encrypt our data in transit. And we employ IP whitelisting for our backend connections. So even if an API is compromised, they can only get to systems they're authorized to get to instead of our whole environment. We do ongoing threat monitoring using cloud native tools and configuration management. And with encryption keys, we don't store them in code. We actually require our APIs to go out and call a secure repository for keys instead of having things stored in code. And we require that of our vendor or our app developers as well. And within the development pipeline, we employ DevSecOps, and we have our different security gates where we check our code for vulnerabilities, and we scan things before they're released to production. And for administrators, administrator access, we employ the principle of least privilege. So administrators don't get access to everything, but only what they need access to. And the same thing with users. We use OAuth scopes so that users are only able to access what they're authorized to access. So those are some ways that we provide security to our APIs. It's just not like one thing like securely developed, but it's multiple layers and architecture designs that keep us secure.
I love that. I mean, you kind of walked through a series of things, both in the building of API, but also in the running of API, thinking about least privilege, thinking about zero trust, which is a hot topic, right? With the new cyber executive order, really is a series of things, encrypting the data, transit and rest. So I love all these things that you guys are putting together. Thank you for that deep dive. Elizabeth, let's jump into CMS. CMS, pays the healthcare claims of over 50 million Americans, right? Has tremendous data about what services they receive, what's effective, and can you talk more about how CMS is working to make data available to insurance companies, healthcare providers, even the Medicare recipients themselves, and how do APIs fit into the CMS mission?
Yeah, so the Center for Medicare and Medicaid Services has a big mission in providing healthcare across the country. One of our first and most successful APIs was, public APIs in particular, was Blue Button, which started in cooperation with Veterans Affairs to very specifically help veterans download the medications that they're taking. Because your typical veteran, if they're getting services through the VA, they also have a regular doctor. And being able to coordinate between the two can be really important. And out of that has grown a lot of third-party applications that can help the beneficiaries manage their own data, download a history of their claims that have been filed on them, and generally give them more control of their data. Some of the next steps are, how do we help people carry this data with them? So, when you end up in an emergency room, your previous health issues can be more quickly identified. And then the specific area that I've been working in is actually in our internal APIs. So CMS contracts with a number of Medicare administration contractors to actually be the interface between providers and CMS for getting repaid for services that they provide. So it's a lot of B2B type work. And one of the bigger issues that we've been running into in trying to specifically modernize payment systems is mainframes. all of a sudden, over the last 12, 15 months, we've been talking about mainframes again. And the security paradigms, the authentication paradigms on mainframes are different than on, I can't say traditional servers because they're way newer than mainframes, but like what most people have been educated on in the last 30 years. Little things like on a mainframe, your system users, or actually, let me say this backwards, your application users are all system users. And you don't do that on servers. Like you have your people who maintain the server, and then you have the people who use your application, and they are two different buckets. So working with that and having to give authentication mechanisms to these 7 contractors for the portal services that they provide, so they can tell providers what claims have been processed, or maybe what stage of the processing the claims are in, has been pretty big. But also, this is actually a really important part of our economy, so we have to be methodical. So we've done a lot of like proof of concept with things that are less sensitive data. It is completely public how much we pay, or how much Medicare pays for a particular service. It's a formula, we publish it. So starting with those low importance data has led to, when you do the security boundary doesn't have to be as hard, but as we are like continuing to grow, we need to evolve how we are thinking about securing our APIs.
Well, so that raises a question for me. I'm curious to go a little deeper into some of the security, if you'll talk about that. And then yeah. I'm also curious about, you don't have a monolithic set of folks, right? There's CMS folks, and then there's different contractor teams, and so and different projects, right, where you're trying to modernize kind of these big legacy systems. So I'm just wondering how you're thinking about security and standard tooling across this.
Yes, very carefully. So a lot of what we're doing to secure the APIs, particularly as we move them into a cloud, follow along what Carrie Lee said. Encryption in rest and in transit, securing the encryption keys that you need. We also do a bit of working through private intranets, so that at least the network boundary, we move out a layer, and it's a little easier to monitor. We have a lot of static analysis going on, and one of the things that the U.S. Digital Service in particular often helps with is helping teams move from a waterfall, which creates these monolithic waterfall development process, which can create these monolithic projects, to a more agile testing forward process. So the more tests you write up front, particularly if you're writing both your unit tests and your integration tests, as tedious as it all can be, the sooner you can spot issues. And then you're right, we have a lot of different vendors. There are not just the Medicare administrator contractors, there's the people who run our mainframe data centers, and then the people who do this internal development for us, both the software that runs on the mainframes and the software that runs in the cloud. One of the best things I think we've done is set up a dedicated operations team. So they are the ones who are looking at the infrastructure. I don't know why I quoted it, I guess, because it's the cloud and your infrastructure gets very fuzzy in the cloud. So they help any new developer team come in and here's the pipeline for your development. These are the tools we use, and this is what we expect. This is the process for getting launched to production. You have to, in addition to any compliance paperwork, you also have to do a threat modeling session. So that you can show us that we have talked about what the issues with your project could be, and a tabletop, which could be either just general infrastructure incident or security incident. So to get these teams thinking about it. Contractors will come in with different sets of skills, particularly around security. So the goal is to bring everybody up to a very specific baseline and then make sure that we're learning from the vendors who are above that baseline, integrating new tools for regular scanning to make sure that we are continuing to level up.
Excellent. Well, I want to include Nick in this conversation. Nick, I think you're here by voice, right? Do we have you there?
Yes, I'm so sorry I don't have video here.
No worries at all. It's welcome. You know, we had started off the conversation talking about API security, and then now we're moving into the infrastructure as code, which is clearly related because, you know, a DevSecOps environment or pipeline we're tying together things with APIs, right? So I know you're really passionate about DevSecOps. You co-lead this for the entire DoD and have a specific initiative with Platform One. Can you tell us a little bit more about that?
Yeah, no, absolutely. Thanks for having me. I'm sorry for being late, but I got stuck in a meeting, and of course we don't have camera here, so that's I can't. You can't see me, but you're not missing anything, so that's good. All right, so Platform One, you know, was created about a year and a half ago, and really the goal is to remove impediments to the adoption of DevSecOps in DoD. And you know, when you take a step back and you look at everything that was just talked about today, just in terms of API security, but also identity management and all the moving parts, right, to create a secure stack, you end up quickly realizing that if you want to move at a pace of relevance, you want to bring enterprise services to life in a way that's not a one-size-fits-all, but at the same time bring the right cybersecurity and baked-in visibility and enforcement and zero trust and all the good stuff that we need to use to build secure software. And of course, if you do it in a vacuum and if you let every team build their own stack, you're gonna have a lot of reinventing the wheel and technical debt. And when I started, you know, we had a lot of great teams building effectively what we call here a software factory or DevSecOps pipeline, if you want to call it that way, from scratch, effectively spending often a year just to build a pipeline so they can build mission software. And so I hope we all agree that we're not here to build fancy DevSecOps pipeline, but to actually build mission software, in which case we probably want a team that's responsible to enable all of these development teams to leverage a DevSecOps platform from scratch that's built with the baked-in security, zero trust, and all the bells and whistles of DevSecOps, so they can use it day one and not have to reinvent the wheel. And that's what Platform One is. It's not only we open sourced it, which I think is pretty exciting for the DoD. You know, it's probably the largest open source community of the department, where we have countless organizations, both on the .gov side, on the IC side, the defense industrial base, you know, big primes to small non-traditional contractors, all the way to you know, financial sector organizations, healthcare, using the open source code that we publish with the full what we call Big Bang, which is our DevSecOps platform that can be instantiated anywhere from a space system to a bomber to a jet to a cloud air-gapped public cloud on premise. and it's designed to be agnostic, elastic, and using GitOps and IAC. Back to your to your point, I guess that's the foundation of everything we do. We don't want to have drift between classification levels. We want to be able to instantiate DevSecOps environments on demand. We have big programs like F-35 or all the nuclear programs. They need dedicated enclave. Obviously, they're not going to use a multi-tenant environment. So we kind of provide both at Platform One. We have the Party Bus, which is our multi-tenant environment, and then we have Big Bang, which effectively anyone can take. It's open source and push button deploy and have a full DevSecOps stack day one with Zero Trust, and not just the basic Zero Trust. I would argue, but I'm biased. Probably some of the most advanced Zero Trust stack that you're going to see, with both traditional ingress egress, but east-west traffic, all the way down to container and function as a service. Ready enforcing device state, compliant to connect. ABAC, RBAC. I mean, it's really advanced stuff. And back to your point on IAC and CAC, that's the foundation. We use GitOps. Everything is code. Everything, the source of truth is in Git. And then, of course, we use Kubernetes and containers. So for us, the Kubernetes cluster pulls from Git every minute to see if there's a change, apply the change in staging and then production. No human in production. That reduce the attack surface. All you got to back up is your source code repo and your databases, and you have a full backup of the stack. So it's pretty exciting to see it. Look, it's such a, it's a big investment, right, to build that automation, but it pays off tenfold, right? Particularly when you have programs with dev, test, staging, and pod environments at multiple classification levels. An F-35 would have like 25 DevSecOps enclaves. Right. Imagine if you have to run this manually and update each container or each tool manually. That would be a disaster of drifts and differences between clusters. And you can't trust automation. You can't trust hardware in loop testing. You defeat the point of continuous delivery. So that's kind of what we built in the last year.
It sounds very cool, and I totally get it. I guess the question I'd have is, does that mean that there's a single vendor for each part of the tool chain, or there's a set of vendors, and what kind of security review do they go through to become part of Platform One?
Yeah, so, and that's also why it was so important for me that we enable any company that has a good product to do business with DoD, both fast tracking the contract piece, but also the accreditation piece. We created the Iron Bank, which is our container registry of containers, where we harden and stig and provide base images, so they don't have to do all the stig OS and hardening of all these bits coming from, whether they use, we support 16 programming languages, so they can really pick their poison. And then we help them, right, get their container accredited, often under 4 weeks, 2 to 4 weeks to get on Iron Bank. And then it's a streamlined updating process. So when they have new updates, it self-updates, and we push those containers automatically across all classification levels. So think of the value, right, for DoD not to have to do manual patching and updating of containers. We can effectively update, when there's a CV or 0 day within 4 hours across the department, all these containers as needed. If there's a new CV on a Linux package, we can update the base OS of Linux, and all of these, 650 containers we have on Iron Bank will self-update. If it's a TLS crypto, 0 day, we can update that, and all of these containers will be updated with FIPS compliant, crypto. So all these layering of containers, right? That's the benefit of containers, right? Using layers, so you can piggyback on existing layers to build your capability on top. And by working with all these commercial companies and startup, most of these companies are moving to containers anyway. I would argue companies who don't start moving to containers are probably going to be gone within 2 years anyway. So that's why, enabling them to get access to Iron Bank gives them that certificate to field to be deployed across all classification level and DoD wide. So unlike just FedRAMP, which, by the way, in DoD, we kind of created a very messed up process where companies have to go through a disapproval on top to go to CUI and FOUO data, and don't even talk about classified stuff. That's so difficult. with Iron Bank, once you're accredited, you get access to all classification levels at day one, right? So think of the value for companies, because unfortunately, most of what we do and the money we have is spent on the high side. I would argue 85% of the budget of DoD happens on classified networks. So if you're a company that has a cool product and you can only tap into unclass networks, you only get a 50% of the pie. So we want to enable all these companies to get to the real meat of DoD, which is the high side. And with Iron Bank, they get full reciprocity all the way to SAP, and under 4 weeks, assuming their product is not completely full of CVEs.
Yeah, it sounds interesting because you have so many disconnected, air-gapped systems, right, or environments in DoD, whether those are planes and ships, whether those are special access programs or other things that just cannot function the way that kind of traditional environments do, and need that air gapping. And so I assume that's driving your enthusiasm for containers and Kubernetes as a way to manage those containers at scale.
Yeah, effectively, you can deliver as a vendor, right? You can deliver your SaaS capability as a COTS on a hosted PaaS, right? So my Kubernetes stack ends up being an orchestration stack where these companies can give me their Helm chart or Kubernetes operator or whatever they use to instantiate their product on top of Kubernetes. So we can push button deploy their software on top of any Kubernetes cluster, no matter where it is. And like you said, air gapped is foundational for DoD, and so we need to be able to run it anywhere. So we bring it with us, right? We demonstrated we can put Kubernetes and containers on jets, bombers, space systems, right? So if we can do it on 60 years old jets in 12 days, I'm pretty sure anyone can do it anywhere. So yeah.
Well, thank you for coming. I want to make sure I bring Chris into this conversation here. And Nick had talked about the potential of in a DevSecOps environment, and the way that he's got Platform One set up, of the ability to remediate, the ability to kind of push something across a number of containers and quickly fix a vulnerability. And so that's part of the promise of infrastructure as code: repeatable, portable, quick to provision. But there's also some risk associated with that. I'm wondering if you could give us a little bit of the downside too.
Yeah, definitely. The benefits, like you said, similar to other code-based activities, it can be scanned, stored, version control, it's portable, repeatable, and can be audited. But that doesn't mean it doesn't have risk associated with it as well. We're seeing industries basically adopt infrastructure as code more and more, with repositories of templates that can be reused by others, either inside the organization or external to the organization. And while that's great, those templates can basically have misconfigurations and vulnerable configurations, and you can replicate them at scale very quickly as well. So it's kind of a double-edged sword in that sense. A couple of studies I like to point to is, one from Palo Alto's Unit 42 that, they did a study that found over 200,000 vulnerable IAC templates on the open web that could be being pulled and used by anyone essentially. And then there's another one by Bridgecrew that manage the open source project called Checkoff, and they scanned thousands of open source like Terraform modules, for example, and found 2.5 million potentially insecure default Terraform module configurations out there. So just seeing that is out there and can be pulled and used by anyone within an organization poses a lot of risk. And within DoD and federal government, we're seeing like Platform One, for example, embrace infrastructure as code. With the Repo One and whatnot. And then on the DoD side, you have the Cloud Computing Program Office, which is rolling out a project called the IAC Baseline. They're working with CSPs to basically have hardened IAC baselines from CSPs like Azure and AWS, for example, that can streamline and expedite mission owner ATO activities. We know ATOs can be extremely tedious, time-consuming, and costly. So you can avoid a lot of rework and streamline the delivery of capability to mission owner and system owners. But with that said, you need to implement security rigor into those IAC templates and baselines, because it could be reused by many folks. So some examples of infrastructure as code security tooling. There's basically CSP native options like AWS CloudFormation Guard if you're working with AWS, but there's also vendor agnostic options, if you're using Terraform, which I know Nick and Platform One are big fans of, things such as Terrascan or Checkoff or Open Policy Agent, OPA. And then there's obviously like vendor solutions, Bridgecrew, Accurix, Checkmarx are some of the ones that come to mind. So there's definitely benefits of using these tools. We always hear shift left, we need to shift security left. So by shifting and using these tools, you're able to identify misconfigurations or vulnerable configurations and essentially capture them at IDE or pipelines before they even become provision in a runtime environment. But that takes implementing that tooling and that rigor.
So let's talk about governance of infrastructure as code. And I'll start with you, Chris, and then Nick, maybe you could jump into this. So what is governance? What does it mean? How should people be thinking about automating infrastructure as code governance?
Yeah, so when I think of governance, I think of it as essentially implementing structure and rigor around how your organization is using infrastructure as code. And part of that is, just getting a kind of an inventory of what infrastructure as code formats are we using, how are we using them, who's using them, how are we testing? As I mentioned with the push to DevOps, we obviously want to push code quicker, right? There's an emphasis on speed to delivery, and that includes infrastructure as code. But with that said, you need to implement some security rigor into that, or some governance, as we're calling it. So it's important to inject, some friction and identify vulnerabilities or misconfigurations, but not too much friction where it grinds things to a halt as well. So I think that integrating with existing developer workflows is a great way to go about implementing that governance. Some examples of that could be scanning existing folders and repositories, scheduling scans or integrating scanning into pipeline activities. And you can also look at these various outputs from the tools, determine are we getting a lot of false positives? How are we reporting on findings? How are our teams trending on remediating these findings, within our environments? And so there's not only a need to scan, maybe as part of the IDE, for example, with the developer, some of these tools have that capability to, give them feedback immediately as soon as they are creating these templates before they even push them to a pipeline. You can also do it as part of a pipeline, and then you can scan it as part of repositories and runtime environments. And I want to emphasize, it's also important to, maybe you push something through a pipeline and there was no finding at the time, or you remediated the findings. It's important to continue to scan those templates on an ongoing basis, because as more rules come out, as more vulnerabilities get found, they could be found in future, scans, if that makes sense, even though it wasn't found in an initial scan. So your goal is basically providing actionable feedback back to the developers or folks putting the infrastructure as code in place. You want to make sure you're providing actionable feedback and help them prioritize and remediate those findings and make those findings actionable, basically.
So Nick, how do you think about governance in your role as the Chief Software Officer of the Air Force?
Well, I think Chris is spot on, right? And look, when I think of the risk, right, it's always funny to me that we spend more time trying to assess the problem than fixing it, right? And look, when it comes to Terraform and automation, right, very much like we did hardened containers, we are doing hardened IAC. We're trying to make the default settings already as secure as they can be, although no one is perfect, don't get me wrong. And by open sourcing what we do, we learn it the hard way all the time, but that's the beauty of transparency of open source. I know people love to feel they are secure and live behind a dark wall that doesn't stick in production, but I'm of the opinion that we need to be transparent, and open sourcing the work we do only makes us more secure, in my opinion, but I might be wrong. And by effectively providing these hardened ISE scripts already turnkey, and I don't know why 50 different teams have to harden MongoDB or pick your poison, right? It just makes no sense to me. So we just want to bring that turnkey, have a repository of hardened capabilities already there. People spend so much time writing STIGs, right? And the STIGs just tells you more or less some of the risk, although they are so stale and behind that I'm not sure they still bring a lot of value if they can keep up with the pace of relevance. But then on top of that, what I'm trying to mandate now, really, and I'm trying to work with this on doing, and Chris mentioned the great work of Michael Savage and his team trying to bring this Terraform and automated inspect, profile, and different things. That's the way we want to be, right? We don't want to just talk about the problem. We want to show the solution. And oh, by the way, here's a code, not just to scan the product to see if you're compliant, which by the way they didn't even used to do. You had to build your own scanning to check that out. But oh, by the way, here's the hardened scripts that you can use to deploy, you know, X, Y, and Z tool, and it's already good to go, and it's already secure, and we're going to update it and maintain it.
Yeah, I love the let's do more security in the balance of you know, worrying about security and doing security, or you know, compliance and actual security, right? And there's a role for both, but I'm with you 100%, Nick, that we need to do more of the actual security. Elizabeth and Carrie, I wonder if you want to weigh in on this balance between the compliance and governance versus the actual doing of security.
Right. So one of the things we see often is that if everything's compliance-based, it's a lot of check the box versus actually making things secure. And one of the common audit findings that people get in FISMA audits is that you're not implementing your controls consistently. And I think infrastructure as code allows you to do that. It allows the security people to actually put their controls into code, and then as they deploy, the organization is consistent across the board, or at least the ones using that infrastructure as code. As Nick said, STIGs are way behind. We are trying to learn from what Air Force did with Platform One and Kessel Run, and actually, you know, ask our vendors to come up with these secured containers for us to develop baselines and have a code repository so that we can ensure that our environment is secure as well, without waiting for DoD to come out with a new STIG or the VA baseline team to spend 3 to 6 months developing a baseline. So I think security is very risk-based. It's not just control-based. And through DevSecOps and automation, I think we're slowly moving towards seeing, you know, evaluating risk versus evaluating controls.
Yeah, all excellent points. As somebody who has very recently come from the private sector and back into government, the change in the 9 years I was out of how we think about security has been both positive, because there's a lot more thinking about it, and then there's also a lot of paperwork. So looking at how we can streamline the paperwork across different contractors or ADOs has been something that we've been looking at, because chances are you're going to be using a lot of the same infrastructure within. So if you could make it easier for, you know, Team Blue to reuse the things that Team Orange has already been like figured out, like these are the best practices. Those are the exciting things that actually help us get back to having more time to do the fun parts of security.
Yeah, it really comes back to what Nick and the others have said, is like, you know, baking those security controls into those templates, those infrastructure as code templates or those containers, and allowing reuse. And then, you know, maximizing that reuse, or reciprocity, as many like to call it. There's no reason that every security team has to redo these activities over and over for the same architectural use cases. We should be avoiding that and focusing on actual security.
Yeah, so let's talk a little bit about guardrails, Chris. You want to double click there a little bit? Talk to us about how to implement guardrails in infrastructure as code.
Yeah, it's and it actually came to mind when when Carrie made the comment about, you know, paperwork and documentation. I think it was her that made that comment. Anyone that's worked in federal or DoD cyber knows we have mounds of paperwork and documentation that's part of ATO processes that rarely get visited, rarely get updated. Technical folks rarely go look at this paperwork. You know, we can't expect developers or others to actually, you know, go dig through all this paperwork all the time. It's often antiquated and outdated, you know, soon after it's written. if it's ever even documented correctly to begin with. So with with infrastructure as code, we can bake in these, these compliance or these security requirements, whether it's tied to, a regulatory framework like FedRAMP or NIST 853, and baking that into the, infrastructure as code via, policy as code or compliance as code, whatever term you want to use, and baking that kind of stuff in to, prevent, certain activities, let developers be creative and move fast, but also not do certain activities that violate, whether it's, your regulatory requirements or your, organizational security requirements around encryption, password complexity, multi-factor authentication. All these things can be baked into these templates. That way, they're able to move fast and perform their activities, but they can't, stray outside those bounds and do things that kind of violate your requirements. So that's kind of the goal that we're, reaching for in terms of infrastructure as code and compliance as code. So by integrating that into, the templates and the workflows, you're providing those guardrails and, keeping misconfigurations and vulnerabilities from ever kind of materializing. And then you're also, avoiding that situation where you have to have these mounds of documents that no one ever goes and reads. They're outdated. You're basically baking these into your templates and then moving out smartly from there. And it goes back to the reuse concept too. If we all have to adhere to NIST 853 for the moderate baseline, for example, there's no reason that can't be baked into these templates and used by many folks who have the same security categorization or impact level, for example. There's no reason to keep doing this stuff over and over and going out and manually validating it after it's already been put into a runtime environment and it already is a vulnerability at that point.
Yeah, I'm not the security expert that you all are, but to me, it just seems crazy that we write 1,000-page documents that try and document a system perfectly, and all of the security vulnerabilities and what we're doing about it, et cetera. And we're going to tee that up to one person, and one person's going to say, "Great, let's put that on network or let's deploy that to mission," kind of thing. And so, one, I don't know how authorizing officials do their jobs. I'm in awe of them if they're really able to synthesize that and understand that. But I think more importantly, and the great AOs, and they exist all over government, they understand that software is changing, that software is living and breathing stuff, and that this static document representing all of the security, it's a point in time. And so, and we need to have more of a continuous ATO, right? And I know that the Air Force has done some interesting work there. Nick, I don't know if you're able to talk a little bit about continuous ATO.
Yeah, so I'm now also the chair of the because I have nothing else to do all day. So the chair of the DSOG, the DoD Security Authorization Working Group that defines the AO training guidance policy, with the DoD. So for DevSecOps, and so I'm helping. We just released a draft of the continuous ATO guidance. We did a video on my on the software that they have, that Mail website, to show a little bit about what we're thinking about to help the entire department move to continuous ATO. And effectively, it will have 3 pillars, which is, one is the DevSecOps platform. The second one will be the process and the gates inside of that CI/CD pipeline. And then the training, the last one will be the training of the team. I can't get into a lot of detail obviously here, but it's an hour video on the website. So, but it's effectively moving from a snapshot in time of risk, which, by the way, every single time I looked at ATOs, they were completely wrong every single time, compared to even stuff as basic as ingress, egress, port and protocol, basic stuff, let alone the more advanced details. So moving to a continuous dashboard showing, all that data live and showing the traffic, showing egress, ingress, port and protocol, the findings and the pipeline findings, cyber testing, change management enforcement with multiple set of eyes on Git repos. All of this stuff moves us to a CATO, and platform one now is, well, we're not Google. We release 31 times a day in production today, which is not bad.
It's really exciting stuff, the move from a big bang ATO to a continuous ATO. And I know of efforts inside of federal civilian government in DHS and HHS and other agencies. So I'm really excited about this move to real-time risk measurement and really understanding the threat in real time as well. We have better tools for that as well. So that's really promising for. Yeah, go ahead, Nick.
No, sorry, and I guess since we have your audience here, I wanted to let you guys know that we've been working with Ron Ross, at NIST to create some special publications on continuous A2A and DevSecOps. So if you want to bug him a little bit and put a little bit of pressure on Ron Ross and tell him, hey, let's finish those documents so we can publish them and release that. But that's gonna give us the government-wide ability to do this. I mean, honestly, the NIST cyber framework and RMF and all that stuff already enable continuous accreditation. Okay, so that's already something we can do. But having special publications showing DevSecOps, that's really where we want to be.
Now, Carrie, why don't you take us home?
Okay.
I think you had a comment on this, and then some closing comments would be great.
Right. So I just had one comment. It's that one of the challenges we're seeing is that like a lot of the governance risk compliance tools are not able to process automated input, and figuring out another way to be able to show the risk is, the challenges we deal with, because you have your system and it's very manual, click the box, write your documentation, when you can provide automated artifacts that are up to date for every release, and they can't get into the system that actually is being used by the authorizing officials. So that's one of the challenges we're looking at right now.
Yeah, I like this idea of being able to see the artifact on demand and having that sufficient transparency with the right, zero trust, right? Only the people who need to see it should be able to see it, but still being able to see it on demand so that you can evaluate that risk. Final comments, Elizabeth?
Yeah, this has been a really fun, fascinating conversation. Most of my background was originally threat detection and incident response. And one of the things that I really like about infrastructure as code is it tries to produce a more homogeneous environment. And typically in an incident situation, you're looking for the outliers. So the more documented and homogeneous your systems are, the easier it is going to be for your blue teams and your incident response teams to help you quickly. So something to consider.
How about you, Chris? Final remarks?
Yeah, just I definitely am super passionate about the continuous ATO or continuous RMF or ongoing assessment, authorization, whatever term people like to use. Nick has been evangelizing this approach for some time with Platform One, is using that tiered model of maximizing security control inheritance from an IaaS PaaS perspective, and then all the things we talked about with infrastructure as code and APIs. Is moving towards, everyone knows the term like compliance doesn't equal security. Well, maybe we can change that paradigm a bit, right, by making this ongoing authorization or continuous ATO, where we're leveraging APIs and infrastructure as code and cloud native architectures to continuously validate our security controls are in place and effective, and bring, security and compliance more in sync.
Yeah. Well, I hope everyone enjoyed the panel today. I hope you learned a little bit about API security, infrastructure as code security, the benefits of moving to APIs and infrastructure as code to really deliver capability, to deliver mission faster to the American people, to the warfighter, to the veteran, to the doctor, whoever it may be. So the good news is there's existing commercial tools, there's open source tools, there's automation that we can bring to this problem and help ensure that both infrastructure and code and APIs are secure. So a huge thank you to ICIT for hosting this important conversation. Over to you, Joyce.
Thank you so much. This was a great conversation. I learned a lot myself. Thank you, Nick, for your expert moderation. And thank you to our panelists, Nick, Carrie, Elizabeth, and Chris. Also, thank you to Checkmarx and DLT for continuing your DevOps series with this topic. Thank you so much. Have a great day. Live long and prosper.